Welcome everyone to today's Edison Electric Institute webinar, the world's longest subsea interconnector, the North Sea Link. My name is Alikya Malavarpu and I'm a senior analyst for international programs at EEI. Today we are excited to have with us Noel McGoldrick, Business Development Manager at National Grid, Hilde Horgen Thorstad, Project Director for the North Sea Link at Statnett, and Caroline Bradley, Cable Asset Manager and Senior Cable Engineer at National Grid Ventures. They will join us today to present on the North Sea Link, a high voltage direct current subsea interconnector stretching across the North Sea between United Kingdom and Norway. For this project, National Grid received the 2022 International Edison Award. Chris Eisenbray, Senior Director of Preparedness and Recovery Policy at EEI, will facilitate the conversation. Chris is responsible for a number of key business and operations continuity policy issues, including national level mutual assistance and emergency preparedness. As the session progresses, please feel free to ask questions using the chat feature. Without further ado, I will turn this over to Noel to get us started.
Hi, thank you very much for that introduction, Nakia. I have some slides here, and I'm just let me just see if I can share them. Share my screen. Good, just see if I can put this into presentation mode. So can you see my slides there?
Yes, your slides are good.
Great. Okay. So we're going to start off just by giving a little introduction to National Grid and Statnett for people who may not be familiar. So Hilde, did you want to just do a little introduction here? I don't know, do we have Hilde still on the call? Can you see, sorry Alekia, can you see is Hilde still there? She's dropped off, okay. Well, so Statnett is the transmission system owner and operator in Norway. And as Hilde said here, Statnett operates 11,000 kilometers of lines and cables and 150 transformer stations throughout Norway. And they're responsible for obviously the 24/7 operation of the network in Norway. And Statnett and Norway have interconnectors to Sweden, Denmark, the Netherlands, Germany, and the UK. The National Grid organization that I work for is an international electricity and gas company based in the UK and the northeastern US. And we play a vital role in connecting millions of people safely, reliably, and efficiently to the energy they use. National Grid own and maintain the high voltage transmission system in England and Wales. And in the US, we also own and operate distribution systems in New York and Massachusetts. And we own and operate transmission systems across New York, Massachusetts, New Hampshire, and Vermont. The particular part of National Grid that I work in is National Grid Ventures, and we are responsible within the group for developing, operating, and investing in large-scale energy projects in the UK and the US to help accelerate the transition to clean energy. And as part of that work, here in the UK, we have built and developed interconnectors to France, Belgium, the Netherlands, and Norway. And we're in the midst of constructing an interconnector to Denmark, which we hope to go live with sometime next year. So I'm now going to ask Caroline just to give a little introduction to NSL.
Yeah, so I think the first question was, why did we build the North Sea Link Interconnector? So before you do that, you need a business case. There needs to be a reason to build an interconnector. So the main reasons for constructing the NSL interconnector were to increase the security of supply in both countries. For example, the UK has a large footprint of wind generation, and in Norway they have a large footprint of hydro generation. And when one or the other is not generating electricity, then we can transfer green energy between both countries, and ensure that that energy isn't ensure the energy is used for something useful. So next, please. No. So what is the North Sea Link Interconnector? So there was an identification that there was a business and a benefit for both Norway and the UK to be able to share electricity. So how could we do it? It's 720 kilometers away, so that's the route between the two. It is 1.4 gigawatts, which was the optimum power sharing between the countries. And the technology that was chosen for us was a voltage source converter station, which could be used in a bipole, so we can transfer power in both directions. And we agreed that the technology selection for this, because of the power transfer required, and the operating voltage, and at the time we let the contract, a mass impregnated cable was the most mature technology choice for the interconnector. And we commissioned it in 2021. Next. So what is an interconnector? So an interconnector is a way of connecting two countries' electricity grids. And for the UK, with us being an island, we do this via subsea cables. So for the North Sea Link, we have a very long DC submarine cable, and that connects into converter stations at each end of the route. For a long route, you do the transmission via DC because of the losses are a lot lower than they would be in an AC system, but it means you need to build a converter station at each end to transfer the voltage from the DC you've used to transmit over the sea to AC to fit into the grid systems. So we have the converter stations, and then from the converter stations we connect into the grids at either end. And then, so we've now decided on the functional requirements of our interconnector. We know what it needs to do and where it needs to connect to. So the timeline for the project, this is just to show that it wasn't a quick process. So for NSL, a license application was made in 2013. We went through an extensive tendering process, securing of all of the connection agreements and land requirements before you get to actually constructing anything. So we overall it was an 8-year process to get from beginning to end.
Very good. Hilda's had a slight technical difficulty and her computer's crashed, so she's just in the midst of restarting her computer. So I'm just going to change the order of the slides. So we'll come back to Hilda's part of the presentation that Hilda was going to make, and we'll jump forward to some of the technology aspects of the North Sea Link. So as Caroline indicated, we built a voltage source converter station. So what we've gone for is a bipole arrangement. So we've got two poles capable of providing 700 megawatts of transfer capacity each, and we operate then in what we call a rigid bipole. So each of the poles has to be loaded to the same level as the other pole, and we've got two poles one operating at plus 515 kV and the other operating at minus 515 kV. So in total, we've got 1 million volts across the two poles. We can transfer 1,400 megawatts in either direction. And so with 1 million volts and 1,400 megawatts, that gives us an operating current of about 1,400 amps. And I think, well, so we've gone for a bipole arrangement, and that's what we're showing here with two cables. So we have one DC cable operating at plus 515 and the other DC cable operating at minus 515 kV. We've gone for a voltage source converter, which is different to some of the older technologies, current source converter. So because we've got a voltage source converter, we can generate our own waveform, our own voltage waveform, and we can have that voltage waveform either lagging or leading the system volts, and that way we can generate or absorb reactive power as per our kind of needs. So what we have effectively is we've got the AC connections, we have a pre-insertion resistor and an AC breaker. Then we transformers, then into the converter station, and then we go into the DC side. And here on the DC side, we've got a selection of switches and disconnectors, which we use to configure from bipole to monopole and back again. If you look at the connection here, we have just two cables. So when we're in monopole operation, we will use one of the cables as a metallic return. Unlike some designs, we don't have a third cable for metallic return. We have one station or one system ground, and that's in the UK. And this provides a kind of a voltage reference for normal operation. Because we've gone for voltage source converter, we were also able to provide some kind of special grid services. So as well as providing things like frequency response, we can also provide black start capability. So that's under the scenario where one of the networks, either in the UK or Norway, was to go down, we would be able to assist in restarting that network. This just shows a kind of a slight overview of the equipment that the layout that we've got at Blyth. And basically what we've got is a site which is effectively 200 meters by 200 meters. We bring in our AC on this side, and we bring our DC out on this side. At Blyth, we slid this building to the right. It would normally kind of be more central, but we put it to the right just to avoid an oversailing overhead line around about here. But effectively what we've got is we have an AC hall where we have our converter circuit breakers, and we have some pre-insertion resistors, and we have some harmonic filters. Because although we're VSC, we do have a small amount of harmonics, but not very much, so the filters are quite low. And then we connect from here, we connect into our transformers. From our transformers, we connect into our reactors, and then we go into our DC, or our valve, where our HV valves are, where we're converting from AC into DC. And then here we go out and into our DC building. So here we have the switches that I talked about for switching between monopole and bipole, and we've also got our DC cable connection. And this is the site during construction. So this is probably about peak construction. We started construction on the site in 2018, and at our peak, we had about 250 people working on site. So here you can see the DC cables coming in, cutting the ground. You can see that we've just received our transformers, and we're just in the process of installing them. And there's still a lot of work going on site. This all happened, and of course, we had a global pandemic in March 2020. So we had a lot of international workforce. But luckily, we got special dispensation for travel arrangements from the UK government, just because of the nature of the work that we're involved in. And this is the finished site earlier this year. So you can see that you can no longer see where our DC cables come in, and just if you look over here, you can see our connection over to the existing National Grid 400 kV transmission system. Incidentally, we chose this site because this was the site of a former coal-fired power station. So in many ways, this is a symbol of moving to carbon-free technology. And here I've got some pictures just of some of the equipment inside the various holes. So this is the voltage source converter conversion modules. We have four holes, 2 for each pole. This is the in our AC hole, and you can just see some of the kind of switches and reactors and resistors, capacitors. These are the DC cable terminations at Blyth. So these terminations are about 8 meters high. Yeah, and this here is a picture of one of the transformers during manufacture in the factory. So the transformers weighed about 80 tons, and they were transported as a single piece from the factory in Sweden to Blyth. We've got 7 transformers at each site, so 6 in service and then 1 spare transformer. This is the site, the converter station site in Norway, and probably some of the most significant differences between this site and the other site, this site of Blyth, is here the physical space available is much more constrained because we're up in the fjord and there's the construction site, but there just wasn't a lot of space available. The site itself was chosen because we're adjacent to one of the largest power stations in Norway, so it's a strong electrical connection. Some of the other significant things here are this site is outdoor construction, whereas at Blyth in the UK, we're right on the coast, and we were concerned about salt pollution. Here, we're actually about 90 kilometers inland by the time you work your way up the fjord. Another significant difference here is that we've put a lot of effort into building avalanche walls to provide protection against both snow and rock falls that you know associate with freezing and unfreezing. And that was what I was going to say about converters. We can come back to this if there's any questions later. Caroline, did you want to talk through the cable construction?
Yep. So
I'm actually back now. So should we go back in and go back into the order and then?
I don't mind, Hilde. We can. If you're ready to go, we can go back to your. Yeah. So Hilde was going to just talk a little bit about the how we organize ourselves to deliver the project.
Yeah, so sorry about all the confusion, but somehow then you actually demonstrate that sometimes you need to improvise and you have to lean on others, and then it works out all along. So, but thank you for talking about giving the opportunity to talk about the one team organization. And if you go to the next page there, Noel, we set up. We now knew that when we started this project, we had very high ambitious. We had like the key targets that most project has. And we also now knew that we had a strained project program with no float. So today, when we're looking back, it's more than 7 years project duration. We have worked 4.5 million work hours. I think we have succeeded quite well in delivering the project, and we also got this prize to prove it. So therefore, it's a little bit extra exciting to demonstrate and present how we work together to deliver the project, and also to talk about our amazing team. So if you go to the next slide, then National Grid and Statnett, we have delivered several other interconnectors, but not together. And as companies, we have different strengths. And also, I think you can say that British and Norwegian work culture is quite different. Also, everybody knows there's a lot of best practice principles to how to make an organization work. And it seems very easy on paper, but still we know that not every project succeeds in working well together. So when we started the project, we started to think, how can we work to deliver this successful project, and how to build on the best from both companies. And in addition to that, we also wanted that this work experience should be the best ever for all of the team members, so that we could develop and deliver new great projects later. And one of the things that we made, or we built what we call the one team ethos and the one team project organizations. And we actually think the way we work together has been a key to deliver successful projects. So now I'll go a little into that. So if you go to the next, in many ways, when you start a new project, and maybe in particular when you start a new project with a new partner, you are building a whole new business, and you have to agree what to do and how to do this. And most important, I think, is actually to involve the teams that are to work together in developing the what's and how's. Because what you know is that often implementation to make people do what you say on paper we are to do is the hard part. But if the people that are going to use it actually develop it, then you have automatic implementation. And the key tools that we developed is the matrix organization structure, what we call the project management plan, and also the project charter. And for a long duration and long distance project organization, building a project culture is both important and difficult. So if you look at the next page, then we are showing our quite complicated matrix organization. We started out with a quite small team, but at peak load, I think we were 80 to 90 persons. And when you have interconnector projects, like a cable crossing an ocean, it's quite normal to split the scope somewhere in the middle of the ocean, and each partner delivered their part. But we wanted rather a team where resources from National Grid and Statnett work together on all parts of the scope. So we set up what we really wanted to strive was a lean organization where we were covering all project competencies, but without having duplication of roles and not duplication of work, like because we were two partners. So therefore, all key areas in the project include resources from both partners, and we actually trusted all resources to consider the interest of both parties, so that we knew we worked for the best of the project and the best of the partners. And we built the organization on the contract structure with a strong converter team that Noel just talked about, and the cable team that Caroline is going to talk about, but also having support on all the key project areas like quality, planning, risk, fully involved in the work. And another key point is that full-time resources are most efficient. So we, instead of having the super experts maybe on each area, we focused on having that one person had to fill more roles so that we could be less people. Then you have the team members usually become more informed, more involved. It's easier to work together, and it's more efficient than having like a little piece of many persons. The next thing we did, if you then go to the next slide, is building the project management plan. And when you have a partner project, and as we had two strong corporate organizations with their expectations on how to work, we had to develop and agree work process for this project, for this joint team, and then building on the best from both partners, and then avoid having to double control systems. I think when we look back, we think this worked very well for NSL. We had fit for purpose processes. And when you also use the team to establish good enough processes, they know what to do and implementation goes by itself. But one thing, of course, to remember is this is a very long project and several project members are replaced during the project. So when the processes are working well, you stop to think about them really, and then it's easier to forget to onboard new members and explain that in this project we actually work a little bit different than in the corporate. So that is also like a learning, keep on onboarding and keep on learning or implementing. And then last but not least, if you go to the next slide, Noel, we are building a project culture. When we talk about culture or how we work, safety should always go first. And core elements for good health and safety performance is leadership, to have a skilled workforce, and an environment where people feel trusted. Luckily, these are actually core elements for having a high-performing project team. And then, so when we build our project values, we thought like that if we build on these values, we help the team deliver a successful project, and we refer to it as the one team ethos. And we didn't only build it, we actually actively used it not every day, but every week, every meeting. Many projects have something they call a safety moment, where like to focus on safety, they start every meeting with a safety moment. We invented what we call the charter moment in all team meetings, where we use this actively as a tool to talk about and exemplify what goes well, but most and maybe as important to when something doesn't go that well and you are hindered from working together, you could use that as a starting point, like let's talk about the difficult things. And when we say trust, something that has been very important to have trust and work good together is openness and transparency. As an example, if something seems to go wrong or develop a little bit wrong, it's so much better if you give an early warning and not wait until you have a full problem. And also when you involve involve others to resolve the problem. And I think maybe engineers often finds it quite appealing to work alone and find the perfect detailed solution to a problem. But when you are then to introduce that solution to the others, they have to like negotiate all the pros and cons and alternative solutions, and then you have rebattles and everything. But if you involve early to set out the direction, you find a much quicker way to the solution. So I think that has been quite successful in our team. And then to continue on communication, and I think maybe I had a very good demonstration here. When we started in 2015, I think it's almost difficult to remember how poor VC WebEx worked at that time. It was numerous meetings. I can't hear you, I can't see you. And today I demonstrated that it actually still happens. But we had to invest a lot in time to travel, to meet and build relationships. But we also, I think, became professionals on WebEx video meetings, and we used it a lot to actually work well together. But then in 2020, everybody remembers COVID pandemic came, and as many other projects, we had to face new challenges. We had to manage offshore installations. We had to construction sites. We had a lot of deliveries across borders and quickly changing COVID restrictions. What I think we did, we actually managed to maintain the team working well together, communicating well, making efficient decision making. And to some extent, I think the one team and the way we had worked with building a strong project culture acted as a little bit of a vaccine on the challenges with the COVID there. And then also, we even tried to bring this one team ethos over to the next page then, Noel, with the contractors to involve them in how they were thinking. Sorry, we had that one more, that was for the COVID and how that hit us. So one more slide. When we involved the contractors in the one team ethos, we asked them, we had huge safety conferences where we wanted the contractors to learn from each other, but we also tried in our regular communication to build on the one team that we are actually delivering better results for the whole project if we work together on finding solutions, rather than saying like meet you in court, where you often end up with a contractor relationship. So then the last slide I would like you to share then for me, Noel, is I think still it's all about people and to select the right people for the job. And in the NSL project, we looked actively for people with the commitment to work on a one team and a partnership approach that wanted to build relationship and build their teams. And that you actually have personality that you are willing to compromise a little bit, adopt new ways of working. And last but not least, sometimes you actually have to deal with the elephant in the room and do something about it. So then I was planning to go over to cable so that you have a project in the middle.
Yeah. So Caroline was going to just tell us a little bit about.
Yeah, I'm going to talk about the exciting bit, which is building how we went about building the longest subsea cable interconnector in the world. Ooh. Next slide, please, Noel. So there was an ambition to build a connection between the UK and Norway. So the first thing that we did was you take a map and you need to identify a route between the two countries that your cable could travel along. And you do that by a desktop exercise and you try and find the best possible way. But when we get to the Norwegian end of the interconnector, you can see, so the graph at the top shows what the seabed level looks like between the UK and Norway. The far left-hand side being the UK, where it's nice and flat and not too deep. And then where it says lot 1, you start to move into the fjord section and the water depth significantly increases and the variation in the seabed level also significantly changes along the route. Also, this is now granite because we are in the fjord, so it's a very hard seabed as well as being quite deep and variable. Also, as you can see from the bottom map, there are many islands along the way to get along the journey that you need to thread your cable in between, bearing in mind it's not the most flexible of things and you have to get a cable boat to do it. So to confirm this route, we then moved on to doing a survey of the seabed. No? Please. So we did a pre-lay survey. So, and that's the basis for your engineering of how you design the cable and how you can connect the cable between the two countries. So the survey will look at the level of the seabed, the water depth, the makeup of the seabed material. So is it hard? Is it soft? Is it sandy? Does it move? Is it nice and stable? And all of that goes into defining how you can get the cable onto the seabed and safely protect it once it's there. But the other things we have to consider, especially in the North Sea, are the potential for unexploded ordnance, which is what UXO is. And there are also things that are classed as military graves, so any vessels or ships that have sunk during the war, or aeroplanes that might have crashed into the seabed at a certain point in time. So we have to be conscious of all of the history that's happened in the North Sea, and we have to look for it and make a plan to protect it and avoid it. Also, in the environmental regulations within Europe are quite strong, so there are a lot of constraints on us where we have to look for things along the route and protected species and develop methods for how to avoid them. So first you have to find them, and then the other thing is other sea users. So for example, in Norway there are a lot of fish farms and people who make their living from working in the water, so you have to be conscious of identifying where they are, identifying what they do. But for the NSL survey, with such a long route, we surveyed over 1,000 line kilometres, took 76 days, but we managed to achieve it with only 2 first aid cases and 0 well time, which for the project was a really big and significant achievement, because it's all offshore, it's all at sea, and the control you can have as a company on land where you can physically see things is different to offshore, and getting the, as Hilde said, the right values and the right culture in the organisation to achieve that was a really big thing for us. So yeah, so next slide please, Noel. So this is just an example of what you might find on your survey. So even if the seabed is the most surveyed and known piece of territory, when we carried out the previous survey for NSL, we found a couple of things that were not known before. So we saw, if you look at the top picture, the black and white picture, we all got very excited because we thought we might have found an uncharted U-boat. But on closer inspection, it was a fishing vessel that had sank in quite recent past. But it still was not charted, and it was not, the position of it hadn't been located. So this we had to add to the charts and manage our route to avoid this. And also another thing we found along the route near the UK was an Annex 1 habitat, which within the UK we are not allowed to interfere with if there are any other options. So we had to do some work to survey the extent of the Annex 1. So the Annex 1 is a reef type habitat, but you can see from the picture with the 2 white yellow lines on, it's not a reef as you would imagine, all beautiful and lovely colours. It's a moving seabed feature that creates a habitat for wildlife at certain points in time, and then it will move. But for us, it was found close to the UK shore, so we had to identify the extent of the habitat and methods for crossing the habitat without disturbing it too much, and if we were going to cross it, how we would encourage it to be reinstated. So all of these things go feeding into your design. And for that design, the other end of the design, so you've now got a route design, you know where you want to go, you know the seabed, you know the water depths. You then have to, oh,
which way do you?
Yeah, back to the cable one.
Yeah.
So you know where you want to put the cable, but you need to design a cable to meet that, those requirements. So one function of the cable is to transmit the electricity, but the other function of the cable is you have to be able to make it, and you have to be able to install it, and you have to be able to bury it. So now we've got all of the input parameters. So as Noel said, we know what the converter station design is and the energy transfer requirements. We know what the seabed is, the water depth, the seabed features. So the cable can be designed to manage all of those. So we chose a mass impregnated technology because of the maturity of it, as I said earlier. At the time the contract was let, and also it could deliver the power transfer requirements required. So we have a copper conductor with mass impregnated, which is insulation, which is a lapped paper insulation, which is then impregnated with a highly viscous oil, so more like the Vaseline end of the spectrum than oil you would have in your car. There are then some metallic sheaths on the outside for mechanical protection, some plastic oversheaths for moisture protection. And then on top of that, we have 2 layers of armor wire. And the armor wire is there to support the cable when you hang it off the back of the boat to install it in the water. So because we were dealing with such deep water depths and such a heavy cable, 2 layers of armor wire were required to support the cable design. And then you've got some yarn, which is stripy, so you can see it on the seabed, to again protect the cable from the outside world. So that was our design. Next slide, please. And then you have to make the cable. So our cables were manufactured by a company called Prysmian and their factory in Arco Felice. I put a nice little picture there in because it's Bay of Naples, and it's not a bad place to make cables. But to make a mass impregnated cable, there's multiple steps you have to go through. So you strand the conductor, that's one step. The next step is to lap the paper on. You then impregnate it with oil. You've then got more steps to extrude the metal and polyethylene sheaths on it to protect the cable, and then you armor it. If the cable is not being used offshore, you skip the armor stage and it's straight for delivery. But other than that, the cables are the same. So for North Sea Link, because we were making so much cable, our main concern here was we type tested it and we followed all of the CBA guidance. But for us, it was quality control of the manufacturing process was key because we were making such a large amount of cable. We wanted to ensure the quality of it throughout the manufacturing process. So at each stage, we had hold and witness points that we maintained with the supplier, and at those points we could test the cable, and we had also options to go back and test the cable at later dates if we felt the quality was slipping. So that was the key to us being happy that such a large quantity of cable could be produced by the factory. So we've loaded onto a boat. It's in the Bay of Naples, leaves the Bay of Naples and comes to the North Sea. So now we have to get it from the vessel onto the seabed. So, no. So we had 2 companies on the project working together to construct the North Sea Link. We had, as I said previously, Prysmian, and we used Nexans for the Norwegian end of the route. And this was partially or mainly because of the constraints in the supply industry. We needed more than one supplier to be able to deliver all of the cables on time, and also it gave us flexibility with supply. So we've got a couple of vessels. We have Nexans also have a cable factory in Halden in Norway, so their cable was loaded on there. The blue vessel is the Julien Verne, which was Prysmian's old cable lay vessel, which we utilised for the delivery of the cable. Those vessels laid the cable on the seabed, and then where required, the cable was trenched into the seabed, either by using water jetting, or where the seabed was really, really hard, we used a chain cutting tool to chain cut it into the seabed. there was, so the way we did it on this project, we laid the cable on the seabed and then the burial vessel followed behind. But it wasn't a simultaneous lay and burial. So there was a period of time where the cable is exposed because there's a little delay between the two processes happening. And then we get to a cable being buried on the seabed. Yes, that's.
Thank you, Caroline.
Yeah, and Caroline showed the map of the North Sea and then ending into the fjords of Norway. And then we came to the Norwegian end, where we wanted to place, or where we had our converter station in a place called Kvildal, which when you look from the grid, the Norwegian grid, it's perfect. It's next to a huge power station, Kvildal power station, the largest station in Norway, and connected to a huge water magazine. So it's a strong point in the net, and that's what we like. The problem is that the Kvildal station, and here you look at the map, then it's a bit more difficult. There's a mountain in between and then a lake. And we had to cross both the mountain and the lake. And the mountain is very steep. There's not a good option to go over the mountain. So we had to build a tunnel through the mountain and then across the lake. So a tunnel first through the fjords, then through a mountain, across a lake, and then to the Kvildal power station. So this little land or section had to be 2.3 kilometers of cable, and in addition a land cable and across the lake. And Caroline showed the huge installation vessels. When you install these cables, the water depth is a challenge, and on the fjords the deepest is 600 meters, and that means a lot of strain on the cable. The lake that you look at the picture, and if you go to the next slide, that lake is about 200 meters deep, and that means that this is a huge engineering challenge. The cables in itself are quite heavy, and they are normally transported and installed from the vessels. But these huge fjord vessels, you can't get them across a mountain and up to a lake. So we actually had to build a laying barge at the site to lay it across the cable, or lay the cable across the lake. And this barge had most of the equipment that you have on a full vessel, but it was built only for this project and afterwards taken apart. And then we had to also watch out that you don't stretch the cable. So we had to have extra armoring here and also have very stable weather conditions when we lay the cable, and use ROVs to monitor the laying. So if you go to the next page, then it shows very beautiful weather. This is the barge that we built. It took 19 days to construct it, and then 1 day per cable to stretch or to lay the cable across the lake. We planned for this in May, as the cable is a little bit sensitive for cold weather. This May was very cold, so we actually had to heat the cable in a tent before we laid it to avoid damages. It was a happy day when we finished the construction or the laying across the lake. That actually happened on May 17th, which is the Constitution Day of Norway. So the project manager met the cable installation, playing the national anthem and wearing full national costumes. So it was an emotional moment. And I also think that this operation was quite impressive. And we were actually selected in this National Geographic program series, Europe from Above, to explain this operation because it is actually an engineering feat to achieve this, and thanks to our team, but also the contractors team on delivering this. So then over to you.
So converter stations were finished in early 2021, and then the cables were finally completed in summer of 2021. So then we went into a kind of a staged process of testing, and just really want to say it was a big. I don't know how people did this before Teams. We had a lot of coordination. We were coordinating at the converter station in the UK, converter station in Norway, the National Control Centre here in the UK, and also the National Control Centre in Norway, and impacting on the energy markets. But it all worked, and in October of 2021, we went into commercial operation. And since then, we've been flowing power. And just to give a kind of a sense of how the link's been working, this is some flows from over the summer period. The flows on the top are in the direction from Norway to the UK, and the flows on the bottom are in the direction of the UK to Norway. And what we're seeing, well, this year was a particularly dry summer, apparently in Norway, and overlaid, I guess, with the situation in Ukraine, we've been flowing a lot of power in both directions. And our expectation is that for the future, both countries have got a lot of wind. So we've got 30 gigawatts by, I'm not sure what the date is, Hilde, in Norway.
30 gigawatts by by 2040 at least, or in the long term.
And in the UK, we're talking about 50 gigawatts by 2030 of offshore wind. We've currently got about 12, 15. So we're expecting that in the future there will be a lot more variation in the flows, and flows will change in response to weather conditions. So in summary, it's been a great project, and it's really helping to contribute to helping achieve a net zero. And that concludes our presentation. So thank you very much for your time. I hope we've entertained you and provided some interesting little nuggets on the North Sea Link project. Chris.
Great, thanks Noel, Hilde, and Caroline. Really interesting project. Congratulations, number one, both on the project and also winning the EEI International Award for it. We're very proud of it, proud of you. I'm going to start with a question in the chat. This question was asked a little in the early stages of the presentation, so you may have answered a little bit of it. But one of the questions that was in the chat was, why was Blyth selected as the UK terminal? You have other options along the coast, maybe in Scotland and other places. But what was the thinking behind that, or what, geography, length, anything that you want to add on that?
I think there were several aspects. One, it was a strong connection point in the UK. So we knew that if we could connect, like I say, it was a former power station site. So we knew that if we could connect there, we had good connections around, onto the UK transmission system. I think also if we connect the further north, you might connect. I think the electricity system operator here in the UK would prefer you to connect further south, just because there's already constraints on what we call the Scotland to England kind of boundary. Caroline,
there were landfall sites as well for the cables, so it's a combination of the two. It's being offered a grid connection point for us by the system, but also if we can land the cables and if we can find a route from the sea to the connection point. And Blyth fitted all of those criteria.
Yeah. No, thanks for covering that. you did a great job describing the construction, the technology, the technical and engineering involved, as well as the human factor, the teamwork and how to build that trust and that trusted environment. Could you talk a little bit, and maybe this is not up your alley, maybe this is not in your bailiwick, but could you talk a little bit about kind of the regulatory process? You're dealing with 2 countries, different regulatory environments, perhaps. Also how you maybe communicated the project to other stakeholders, whether customers or local communities. How did you get maybe those local communities involved, if any?
I can answer for the UK. Maybe Hilde might say something about regulatory arrangements in Norway. The UK regulator recognises that this is a big project and it's valuable to the UK for helping to achieve net zero. And so in order to support these projects, what the UK regulator has is they've got what they call a cap and floor regime. So we're allowed kind of the reasonable costs of constructing the interconnector, and then we're allowed to make a kind of a rate of return on that, up to what we call a cap. Or maybe if I talk about the floor first, we've also got a floor, so that if for any reason we meet performance criteria, but if for any reason the value of the interconnector has reduced, the UK consumers will underwrite our returns at a minimal level. But in return for getting that underwriting, we give away kind of super profits. So, for instance, one of the things that happened earlier this year, and maybe in response to Ukraine and very high gas prices, is there was a large disparity between, in terms of cost in the UK and cost in Norway. So we ended up collecting a large arbitrage rents. But because we have this cap and floor, we don't retain them. We give them back to UK consumers. So
how about on the Norwegian side of the equation?
It's not exactly the same, but it's a bit similar. That and we are and then the national transmission system operator. We also shall go in zero on the tariffs in the end. So it's a little bit similar to what there. So when you have surplus incomes like we have this year, that is actually given back to the consumers lately. But you also asked about stakeholders, and I think that's a very key point for a project like this. And I think we worked very actively, and we were actually quite welcomed by the local stakeholders. On the Norwegian side, we were, as I said, in a region with a lot of hydropower production, so they're actually quite used to having big projects like this, and they also welcome it. That they know that it's great socioeconomic value to have projects. On the UK side, in the Blyth area, also actually really wanted new business and welcomed us a lot. And we were very active in the stakeholder communication. We built up an education center in the Blyth side to promote engineering as a trade, like that we wanted to make students go into the engineering business, and trying to explain what they could learn and how they could go that way. And we worked a lot with the local schools, like the neighbors that are most affected, and how communicate a lot, regular information to the community on what they could expect of huge vehicles, noise, whatever, so that we were working good together, having an ambition to be a good neighbor.
Great, great answers. I think we have time for one quick question, which is probably a one sentence or one word answer. And then another question is a little longer, but we'll wrap it up after this question. The first question is, what was the diameter of the cable? This is the short question. I think, Caroline, that might be your department.
Yeah. About 13 centimeters ish.
Okay. That's
Ish.
13 centimeters. Okay.
Yeah.
Great. And then the second question is, from a project team perspective, you transition from construction of the project to kind of operations and maintenance and the project being in service. How did that change the project team? Do you still have people who were on the original project team in the construction phase, and are they now in the maintenance and operations phase, or is there a whole new team, or is there a mix there?
I can try to answer a little bit at least, and some of us are still in the project. Often, even if you have the asset going into operations, there's a phase that you have to close down the project, and that takes time to have all the documentation and everything in place. But what we did, and what I think is quite important, is that we had people from the operation and maintenance phase as part of the project team in the construction phase, so that both that we understand the requirements from the operations and maintenance, but that they also learn to know the assets and learn how to operate and maintenance them later. So yeah, that was maybe a short answer to that. I don't know if you want to add a little bit, Noel, on that.
No, I think that's good. I mean, inevitably, there's a lot more people involved during the construction phase than when you go into operations. But some people have moved on to other projects and other work, and then a certain number of people stay in the operations.
Well, again, thank you for your presentation, and congratulations on the project. I'm sure there's going to be a lot of learnings that come from this and other projects around the world and in Europe that are considering something like this. I'll turn it over to Alekia to wrap up. So thank you again.
Thank you.